if you're representing that equation, again, you're not going to draw balloons and blocks and everything all the time, but I think it helps as a starting point. That's a positive term, it's like a block. That's a positive term, it's like a block. But this is like the balloon on the balance, right? How do you counteract the 12 here? How do you counteract that? With one of these, right? Negative 12. You counteract it with one of those. Because what do these two things add up to on this side? What do they add up to? Positive 12 and negative 12, what do they add up to?
0.
They add up to 0. You just have x all by itself on this side. What do you have on the other side? You got negative 30 and negative 12. What do you have?
Negative 18.
Negative 42, right? Two balloons are making an even bigger balloon, right? Two balloons make an even bigger balloon if you're adding them together. Negative 42. If you're still objecting to the drawing the blocks and balloons, I have news for you. When you're doing this later on, this is all you're doing. You're drawing that, right? It's the same without the shapes. Okay? I think it helps to start with, at this point, drawing them because it helps you avoid mistakes. Think of them whether they're blocks or balloons or whatever. You should be copying this down if you haven't already. Okay? What about the second one here? This first thing here, is that a block or a balloon? This is a balloon, right? It's a negative 26. We're going to put a red circle around it. What about the x? It's a block, right? It's a positive thing. What about the 18? You're not sure about the 18, right? This is the one we weren't sure. It's a balloon. The sign has to go with it. If it's subtracting 18, it's like adding negative 18. That's got to be a balloon. How do I counteract it? At the end, I want to just have an x, and I want to say what that's equal to on the other side. How do I counteract this negative 18? How do I counteract negative 18? With a positive 18. I'm going to put a block that says 18 here. If I do that on the other side, I have to have 18. I think it's a really good idea to put a big, huge vertical line down where the equal signs are and always keep the equal signs on that line so you don't get lost. Keep the equal signs lined up vertically and you're really likely to avoid mistakes then. What do I have on the right side? The right side, what do these two things do to each other? They perfectly balance out, they add up to 0. It's like they don't need to be there, they disappear. What about the left side? Negative 26, but then 18. Well, if the balloon is bigger than the block here, it's going to be a balloon, right? How much is it going to be? It's going to be that, right? Negative 8. The solution to that thing is negative 8. What about the third one here? How do you represent this? Do you have to represent with two separate things on the left side? What is it? One big block that's 12 x's, right? One big block that's 12 x's. What about the other side? It's one big huge block that's 60. Okay? If you want to do this, this is hard because you're not adding or subtracting, like you're not adding another block to the side. What you're doing is splitting this one up. You're dividing this by 12. If you divide both sides by 12, what is it going to give you? If you divide both sides by 12, what is it going to give you? 12 x's. If you divide that by 12, what do you have? Well, let's do this side first. If you divide this side by 12, what do you have? You just have x, right? All you have is x here. You have one single x. If you divide the other side by 12, what do you have? You have 5, and it's positive, right? If you have a number that's multiplied or divided, you're not going to add or subtract another balloon there. You're going to do an operation. You're going to divide by 12 or multiply by 12. All right? What about this? This one's hard to represent. because you got x divided by negative 8. It's really hard to represent that. I'm going to do this without drawing the blocks or the circles or anything like that. I'm just going to show the inverse operation. I'm first of all going to write this again just so I can write next to it. I want you to see what's happening here. It says x, and it's divided by negative 8. That's what that line means. Okay? X divided by negative 8. What's the inverse of dividing by negative 8? Multiplying, right? You are going to multiply both sides by negative 8. Multiply both sides by negative 8. If I want to show multiplying both sides by negative 8, this is all I have to do. Put some brackets and put a negative 8 beside it. That means multiplying. And this is multiplying by negative 8. What do these two operations do to each other? Dividing by negative 8, timesing by negative 8. What do those two things do to each other? If you perform two operations that are inverses, like dividing by negative 8, timesing by negative 8, or like dropping this on the floor and picking it up off the floor, or stealing your booklet and then giving you back your booklet, or opening this and then closing this, or punch it. No, just kidding. You can't unpunch somebody, right? You can't punch somebody and then unpunch somebody. There's not really an inverse operation for that, right? Punched you in the nose and broke your nose. You can't unpunch them and unbreak their nose. But if you could, what would those two operations do to each other? You're back where you started, right? If you divide by negative 8 and then times by negative 8, what do you have on the on the left side? You're just back the way you started, right? Somebody punched you in the nose and broke your nose, and then they unpunched you in the nose and unbroke your nose. You just have x. What do you have on the right side? You have a big number, don't you? Negative 40 times negative 8? What is that? 320. That's the solution to that equation. This is what this means, inverse operations. Okay? Again, the first three I drew, sort of boxes and all that. All you really need to do is you're going to draw it without this. You're just going to say, you're going to say if you have that, if you have x plus 12 equals negative 30, you're going to put a big line down the middle, and then you're going to say, I need to subtract 12 from both sides because it's the inverse of adding 12. If your equation has x and then it has 12 added, you can subtract 12 from both sides because these two things cancel out. And you're just going to have an x. Okay? When it says using inverse operations, that's what you're going to do. You don't need to draw the blocks and the balloons or anything from this. You can just take the equation and undo the operation that's done. I would put a little box around where the x is. That's what you're trying to isolate. I'd put a big line down where the equal sign is and keep the equal signs lined up. And then if you notice that there's a 25 subtracted, you say, what's the opposite of subtracting 25? Adding 25. So you put plus 25 right underneath the other 25, but you also need to do it to this side because what happens if you don't? It's not even, it's not equal anymore, right? If you want to keep the equal sign there, this cancels out, it disappears. You don't actually have to cross it out because then we can't read what you're doing. And then you can even go to your calculator if you're not sure what that is. Negative 210 plus 25 is going to be negative 185. Okay? And there you could even put a nice big box around your answer. Can you finish this? And then you need to do some of these. When I'm checking these questions, I know some of you are in the habit of just putting your answer. Number 1 is 3, number 2 is negative 7, number 3 is negative 144. This is what we need to see, or I can't count any of the work that you do. You need to have the question written out. You need to have some steps shown like this. That's what we need to see. Okay? Now and after lunch, I'm going to come around and make sure that you're doing this right. Make sure you're showing what you're doing. It isn't that I don't doubt that you can... It's good if you can see the answer in your head without doing it. You need to get in the habit of the methodical approach to it. Okay? It's really hard to convince some grade 8s of this when you haven't done the later on stuff. The later on stuff has 10 steps to get to your answer. If you don't learn to show a step when there's one step to get to your answer, you're never going to be able to do the stuff that takes 10 steps to get to your answer. If you're saying, again, there's usually only one or two stubborn people that are, this is stupid, I can see what the answer is, you and your steps, it's a waste of time, why can't I just put the answer? It doesn't work once you get the ones that take 10 steps to get to your answer, right? It's not even that far in the future, but in grade 9 you're solving equations that have, lots of variables, lots of terms. You can't see what the solution is to that just by looking at it. Okay, can everybody look at that equation? You need to learn to work down the page and work in a methodical approach one step at a time. Right now we're doing one-step equations. These are called one-step equations because there's one step to get to your answer. Do yourself a favor and teach yourself to write that one step and then the answer. When some of you say, I totally don't get this, what it usually means is, this is the first I've ever seen of it and it doesn't come instantly to me, right? That's what it means. When someone presents you with a new idea, sometimes it doesn't just click right away. So spend some time thinking about it and you'll get it. Later on, you'll think this is the easiest thing in the world. Unless you sit there being stubborn about it. Okay? Can you get to work, please?